Last time we were discussing the life cycle of systems analysis and design, and we looked at the first 3 steps in the so called life cycle, namely requirements determination, requirements specifications, and feasibility analysis. We very quickly we can recap that requirement determination is to decide what actually is the area in the organization which requires the assistance of computers and a computer based information system. And the specifications of course talks about the actual details of what is required, and feasibility tells whether what is required can really be implemented in practice or not. I am very briefly saying this because we will look at each of these in much greater detail as we proceed. The 4th step is called final specification. That in other words, the requirement specification which is arrived at is the preliminary requirement specification, and we have to look at the feasibility of meeting that requirement, and that requirement may be met in several ways, and we have to find out the best alternative, and only after we find out the best alternative we draw up the final specifications of what is going to be the final system which will be implemented. And having decided that, you decide as the next step what hardware is required to be able to implement the system. Hardware specification used to be a very large area of work in the olden days. What I mean the olden days is about 20 years ago. Today that is not very important, as important as it used to be, primarily because of the fact that today almost everything is network based, and PCs or desktop computers have become extremely powerful, and desktop computers are really connected to every other desktop computer. So hardware study today really means how to implement it on a network, but I cannot be very general because a lot of transaction processing systems which I have talked about require very high processing power, huge amounts of storage, and very fast response. Those types of systems are implemented by what are known as servers, large servers. Large servers are many types, and so there is still certain amount of relevance in hardware study, because the larger companies which provide service, particularly for banks, insurance companies, and they look at huge volumes of processing, particularly if it is online, look at the class of machines which are not the PC class of machines. What I mean the PC class is Intel type, Intel Pentium and processors of that type. They have machines like the IBM's own line of server hardware. Similarly, HP have their own servers, Sun Microsystems have their own servers, and so they got different technologies and different specifications for that kind of a hardware. So the hardware study is now relevant for very specialized applications. That is mainly high volume transaction processing applications, particularly things of that like railway reservation system is a huge system, or airlines reservation system, which again is a huge system. And all of these are at the background processed by the what is known as mainframe machines. Even though that terminology today is not all that clear, but they are different types of machines, not desktops. They have got multiple processors sometimes, and they are very fast. And having come up with the hardware on which you want to implement, and having come up with a specification, you go through the system design. System design is the area where a lot of work is done by the systems analyst, who draws up the overall specifications of the not only specifications, based on specifications, the various components which will make up that particular system. So, system design is ultimately a system which will be implemented. So, having decided on the system design, the next is implementation. So, you have designed the system, you know the hardware, now you have to implement. That means write programs, write documentation, test the programs, make it operational, install it on the machine, make it work, and deliver the final product, whatever you promised the customer, to the customer, so that the customers can start using that system. And the whole idea is you should, by this stage, have done have taken all the bugs out of the system, that is, all the errors out by reasonably extensive testing. And so, the implementation would really give you as an end product a reasonably stable, something which can go online and people can start using it. And once they start using it, it should not get into all types of hang-ups and stuff like that, which will put off the customer. In other words, the system has been implemented and delivered, and then at that time it starts giving you error messages and suddenly stops and so on while you are using the machine, then of course the entire confidence on whatever you have done will be lost, and there will be maybe even think of falling back on the old system, and so that should never happen. So, implementation, at the end of the implementation, what you should deliver is a quality product whose quality is reasonably assured. And now evaluation is the next step. Evaluation is not as soon as you finish or implement, but after the system is being operational for a certain period of time, when people have had an opportunity to use the system, and once they use the system, they know what the problems of the system are. In other words, they know at what points the performance is not as fast as they wanted it to be, or they find out that certain things which they thought the machine will do or the new system will do, the system is not doing. So, there is a lot of, you might say within quotes, dissatisfaction with the whatever system is working, because whatever you may deliver, 100% satisfaction will not come very quickly. And of course, the problems in the system will become only evident over a period of time, because all computer based systems have a interaction of both programs, machines and men or human beings. And it is not a computer, it is something which is intended for people. So, people become a part of the loop, and people have certain responsibilities. in making the system work effectively. What I mean by people have responsibilities are there are people who are supposed to prepare data and give it at the right time, people who are supposed to be able to look at the reports and take actions. There are a lot of people in the link or in the chain. You are starting with the raw data being given and even with the actual use of the final reports or whatever are produced by the machine. So, humans actually system is intended for human beings. So, it has got to be such system that has got a good human computer interaction or good graphical user interface and human computer interaction, so that the humans who use the system are reasonably happy with the system. I am using the terminology human just to avoid the feeling that if I say either man or woman, today both men and women use machines. In fact, in many of the organizations, women dominate in terms of the number of positions in systems design and so on. So, it is a neutral thing I am using, even though it looks somewhat artificial to say humans, okay. But we have I am using that with that general idea that it is all people, all persons, regardless of their sex, okay. And the evaluation, after a period of time, you create some kind of an evaluation report and say what you find are the drawbacks in the system or deficiencies in the system and what way it can be improved. Once that is known, then you go through a modification, system modification. That means you improve the system. Sometimes a modification may just not be just fixing bugs, removing errors and so on, or making the GUI or graphical user interfaces better, but sometimes you may even have to implement newer applications which are not thought of earlier. So, modification not only means it is the correction of or correction of existing system, but even implementing something new, okay. And no system, particularly software system intended for organizations, is ever static, because human systems change, human requirements change, and people always say that computer based systems are used by managers to debug their own minds, because they exactly did not know what the machine can do and what the machine cannot do. From the point of view of the companies, service companies as well as software development people, in some sense it is very nice, because once you deliver a system, if that system is going to be used continuously with no change, there is no more revenue for you. If the modification, every time you modify, you ask for more money. So, there is a revenue stream, money goes on coming continuously. Even though you completed a project, the project would continue to give you some money in terms of so called maintenance, and maintenance are of both types, both modification and correction. Correction, of course, people will not give you much money, they will give you some, but not much money. But for modification, you have to say that because you asked for a modification, I am modifying, and so there is a certain amount of cost involved. So, this is important. So, the system modification is continuous, and there is a good relationship between the provider of system to the organization and the organization itself, and if there is a good relationship, then the provider gets continuous revenue and continuously improves the system as and when the organization goes on changing. So, the organizations, as I said, are not static, and so systems are not static. So, continuous system modification becomes a part and parcel of any software system. In fact, the word software itself implies it is pliable or it is changeable, and so people think that it can be changed at no cost and with no time delay, but it is not true. I mean, all of us know that any improvements or any changes of an existing system does not only mean that we have to put more human resource on that to work out the system, but also it requires time and requires a lot of effort, and so that's the perception among people and managers and so on that it should be so easy to change software is not always true. But one thing, of course, a software designer has to keep in mind is that change is going to be the order of the day. Change has to be planned. In other words, you have to assume when you start designing a system that the system is not going to be static. System is going to be dynamic. If it is going to be a dynamic system, that means you have to build a system not for stability, but build a system for change. That is the basic difference between designing certain types of engineering systems, like for instance a power generating station or a building. When a building is built, it is not expected to be changed every year. It is something which is a structure which is for perpetuity is supposed to work without any major modification. Same with generating stations and so on. There are engineering systems. The engineering systems in fact are designed for stability over long periods of time, whereas software engineering systems, even though they are engineering systems, are not designed for stability in the same sense. They are built for change. That is, in other words, we have to design the system, and the methodology of designing system must be such as to make sure that change will be inevitable and change has got to be catered for, and change is part of the design process. So, all the new methods of actually designing systems is using methods such as building blocks, where a number of building blocks are put together, and whenever some requirement is made, you can remove one building block and substitute another building block or add up some new building blocks. So, this is the kind of design which one has to do. To take an example which is familiar to you, nowadays large number of buildings, particularly intended for software industry and so on, what they do is they put a lot of pillars and make huge halls with no walls at all in between. And then when that huge hall is made, then the company make those cubicles, or they put wooden partitions, nice looking partitions, and they have a number of desks, with each desk catering to one person, with a workstation with some little moving space and a drawer and some place to put your books and stuff like that, and notice board and stuff. Each one is designed nicely. So, you got a number of desks made, and tomorrow if you want to kind of reorganize that space and add more desks and so on, you do not have to redesign the building. The only thing you have to do is move around those partitions. So, the partitions moving around is not expensive. It takes time, it does disrupt the operation, but the disruption is slight, and it is not like breaking walls, masonry walls, bricks and so on. it is much simpler. So, that kind of a design is a flexible design and which is designed for change. Same way in software, every design which you make has to be made keeping that in mind. So, whatever you learn in computer science, starting with programming to system design to object oriented system, what all the advances in programming and object oriented design and so on have all the same objective of trying to do two things. One is to make it easy to modify programs, modify systems. The other is to reuse. In other words, be able to not reinvent the wheel every time. One of the things which engineers do in design is they make components and then they try to assemble the components to make up a huge system. And the same components can be used in several applications. Same way, the computer people have been trying over the years to say what are the components in software. And particularly if you are looking at a whole set of applications which are similar, there will be similar requirements. So, that can you think of what are the reusable blocks with very little modification, very little change can be reused again and again. Any software company which is able to make or build systems with good, well tested reusable blocks is the one which in the long run will make a lot of money or make a lot of profit, because they will not be redoing the whole thing again and again and again, and they can finish projects faster and they can make it also work quicker and it's all well tested, and so it also make the customer happy, because whenever a customer requires a change, you are ready for it and you are able to make that change. So, these are the basic ideas which every computer science student has to know, because when you do computer architecture where you are talking about hardware design, there also to some extent this is always used. In other words, all current computers are designed using integrated circuit chips, and each integrated circuit chip has a fairly large functional requirement which it meets, and there is a library or availability of a huge number of these chips, and those chips are used on motherboards and so on to make different types of machines. So, these are hardware IC chips. Similarly, people have been saying why not make software chips in a similar idea and have a library of software components, and then you put that together, like for instance a set of building blocks or chips, and have an interconnection system which will interconnect all these and make the system work. So, even though I am digressed a little bit from this, the idea is so important that it is worth emphasizing again and again and again in almost all courses in computer science. Now, let me go through each one of these in some great detail. And requirement determination is primarily concerned with determining what is perceived as the needs of an organization with ultimate goal of improving their operations, improving their profitability. So, it is not a question of only day-to-day operations. The day-to-day operations get streamlined, that of course is very useful. Besides that, they also want to have information come out for practical and strategic decision making, which will be more profitable. So, requirement determination is arrived at by consensus among managers, and not only among managers, you also normally have in the loop the working people, the people who actually are going to ultimately use the system, and they are going to make or break the system, because they are the ones who are supposed to give you the data, and they are the ones who are supposed to effectively run the system and so on. So, those people's confidence has to be taken into account, and they having a lot of experience in the organization, they know a lot of things which is important for you to gather. So, that is part of the requirement determination, and you have to set priorities among all these requirements, because there will be multiple requirements, and pick the high priority application. Let me give an example which is very something which all of you will probably understand. There is an example of suppose you want to build a house. If you want to build a house, the first thing you do is that you have to take a decision whether you require a house or not, because you may require a house built in a suburb which is far away, or you may like to buy a flat which is right in the middle of the city. So, requirement determination is not one thing saying that you have decided that you have to build a house. You have to find a residence to live in, and based on the consensus among all the people in the family, you talk to all the family. Some of them would say that I would like to be in the middle of the city. Some would say it does not matter if I go out a little bit because it is quieter, and I can have a lot of moving space in the house. So, there is a requirement is there that I need to have a place to live. So, the question is in terms of various alternatives which are there, okay, and priorities you have to assign. And having determined what you want to do, in the case of say a house, having decided that you are going to kind of build your own house, there is one particular path you take. If you decide that you are going to buy a ready-made flat, then there is not much of a future decision you have to take, except that you have to decide where to take the flat, which area it will be, what size it will be, how much can you afford, stuff like that. So, but then that is a different issue. First is question of requirement determination is essentially determine that I need a house and where that house will be. The requirement specification is the next step, that is having determined the requirement. There could be multiple requirements. For instance, a company may say that I require, let me take again a simple example. You take say a shop, a small medical shop, and question about the requirement determination for him would be, do I require a computer or do I not require a computer? Can I continue with my manual process? So, determination at that time is to take a decision between the two, and before taking a decision, of course, he will consider a lot of things. A machine is going to cost me money, whether it requires power, continuous power, it requires certain knowledge about operating the machine and so on. So, do I have that knowledge? Do I have the money? What is the profit which is going to come out of that if I use it? If I do not use it, what is the disadvantage? So, all that has to be considered at the back of his mind before he determines that the machine is required. Okay. And he also may have many choices, whether to buy a laptop machine or a desktop machine, whether to buy a low cost desktop machine or a high end desktop machine. So, all these things also again depends on the what use ultimately is going to put to. Then he might ask the question, do I need an internet connection or you don't need an internet connection? Okay. If I put an internet connection, it is going to cost me money. What is the return I am going to get from that? Am I going to use that at all? If I am going to use it, then it is worth putting it, otherwise it may not be worth putting it. These are questions which the shopkeeper definitely has to ask himself before the requirements determination. So, at the end of the requirement determination phase, he may decide that he wants to buy a laptop. The reason may be that during the shop hours, he will have the laptop. Laptop of course has certain backup power, so he does not have a separate UPS and connect it to the mains, and even if the power fails for about 20 minutes or so, he is not disrupted. So, he can continue to use the machine, and he can always connect a printer and all that for it, which is one of the requirements normally in a shop, because he has to give a bill. And he may decide that he can order medicines by internet, by email. So, he may decide to have a connection to email system, and he may decide that a little accounting package is required so that he can make an accounting. And at the end of the day, he may decide that the reason why he may have gone for a laptop or a portable is that at the end of the day, he can carry the portable home and use it for other purposes. Okay. His children may like to use it for playing games, for all we know, for whatever it is. I think something which is not locked up in the shop, and he also may think that if he takes it home, it is safer. That is, put it in the shop and the shop is locked up, it may be, somebody may take it away at night. So, because laptops nowadays are a very attractive item for thieves, along with cell phones and so on. So, he may decide that it is better to take it home and use it, maybe even for the fact that he can take it home and complete his accounting job. That is, he has done all the collection and he need not sit in the shop and do all the final calculation. The final collections of the day he can get from the machine at home and compare it with what the cash collection he took, and he can reconcile and all that. That may take an hour or two, which he can do at home after the shop is shut. So, these are issues which individually the person has to decide, and so that is what I mean by requirement determination. So, determination at the end of it, he decides what machine to buy, what applications he is going to put on, and why he wants to put those, and what he will use it for. Now, having done that, you have to come up with a specification. The requirement specification is in a sense of a large company. The large company may have a lot of different types of requirements which the company may have, like payroll it may have, and as I said, there are many functional areas which you looked at. Each functional areas has a requirement for an information system. Among these functional areas, a specific company may decide that they may not look at all the functional areas at one go, or they may look at some of them, or they already have an existing system in the organization and they are not satisfied with some of the systems, some of the functional areas, they may decide to only go for that functional area. So, these are all specifications to be laid down in terms of the what is to be done in greater detail. Okay. At this time, you don't worry about how it is to be done, you only say what is to be done. And this specification are arrived at by users' requirement after discussion with lots of users, and it will encompass several applications and several requirements which are originally looked at. Let me again go back to my house example. Assume that the house owner has decided that he is going to build a house of his own, okay, and he has decided to build a house on his own for some reason. Maybe he has a plot which is lying idle, and he would construct a house there, and he has decided at the end of the requirement determination phase. The requirement determination phase said that they have to take some residence. The residence was ultimately decided that you want to have a house of his own. So, having decided, he has to come up with the specifications of the house. What is specification for a house? It's a plan. So, he normally, what does he do when he has decided to build a house? He normally calls an architect. An architect's idea, there is a lot of difference between architects and engineers in the civil engineering field. In civil engineering, architects are the ones who are supposed to look at the needs of people who are going to live in that house, and the civil engineer or contractor is supposed to actually build a house using whatever materials are available at the cheapest cost and deliver the house to you. So, he is more in the implementation part rather than the system requirement determination, the specification part. Requirement specification in this case again has to be arrived at by consensus, because the architect may come up with a plan for the house and it will be a preliminary plan, but members of the family may have different requirements. The grandfather and grandmother may ask for a large puja room. Okay. The children may ask for a separate children's play area or a children's room. The mother may like to have a separate room for music or whatever. Okay. And they may like to have a fairly good kitchen, fairly large kitchen, because she will say, a lot of my time I am spending in the kitchen, I want to have a good kitchen. And the father may like to have a study where he sits down and does his own study and so on. And there needs to be a living area and dining area and all that. So, each one has a lot of requirements, and if you put down all the ideal requirements and put together, it may become a palace for which neither you have the area nor you have the money. So, now what you have to really do is to sit down in consensus, arrive at consensus, saying that, look here, I cannot do this because of this reason, and generally people are reasonable, and you come up with a consensus based on the agreement among all the people of what is the priority, what is the highest priority now, and how to meet that priority. So, you prioritize your requirements, and having prioritized the requirement, you draw up your own rough plan and you give it to the architect. This is my rough plan, and it may be a 2-story house where I require a bedroom downstairs for my older people in the family and so on. So, that requirements are all met fairly with consensus among people, and based on this rough plan, the architect takes that rough plan and makes up a modified drawing. And the modified drawing is again given to the family, and they look at the modified drawing, they may suggest changes here and there and make a third modification. And third modification normally is the time when architect and the head of the household sit together and arrive at a final plan. Now, when that final plan is arrived at, there is only a general plan. Besides that, in any house, you also want to have a looks and feel. People would like to say that from the road, if I look at the house, it must look pretty in some sense. Okay, and there is a the kind of the view of the house, perspective view of the house. Perspective view in terms of plan is only the two-dimensional, whereas perspective view is a three-dimensional. The architect may even make a model with cardboard and so on and give you the cardboard model of the house, so that you look at it from all sides and feel how it looks like. And you are generally, again, there are some people like certain looks, some other people do not like certain looks, but finally they again come up with a consensus and decide on a particular type of design for the house. At that time you gel it. And now, of course, nowadays modern architects also use computers. Okay, so they provide a walkthrough through that house on a three-dimensional computer. Will design nice package, and that package will zoom and change and so on. It will give you a virtual reality feeling of walking through the house and looking at the house from outside. So all these things are now become the applications of machines by architects. Of course, normally for a house they don't go through that all that elaboration, but we are building a huge office building or a new software campus, like all companies are building all the time. Then the architect may give you even that the entire campus layout and a walk through the campus and stuff like that. So these are all done nowadays. See, so at the end of that you are reasonably clear on what you are going to ultimately get. So the one advantage of civil engineers at least is that once having decided on that plan and the elevation and all that, you gel it, and you know that once the house is built, you are not going to be able to change it. So it is a fixed one. So you are very careful at that stage in giving a proper specification. Whereas unfortunately in software systems, people are always not all that clear, because they are under a false impression to some extent that things can be changed at the drop of a hat. So if things can be changed just like that, because it is software, they don't spend enough time at the time of deciding on the requirement specification, assuming that they can take a decision later on, which is not always true. So it is the duty of the designer, system analyst, to point out to the customer that it is reasonably gelled at this stage. It is not easy to change it. If you change it later on, change your mind, it is going to cost you money. So there is a system requirement specification document, is kind of at least preliminary document is put up, okay, at the end of this step. Now, having put up this specification document, you look at they could have the requirement could be met in different ways. So system requirement specification only says what is the requirement you are going to meet, but how you are going to do it, there could be different alternatives. So you can have 3 different alternatives and look at the feasibility of each of these. Feasibility means the what is the priority which you have put, which priorities does it meet, at what cost does it meet, is there a cost benefit of the system, among the 3 alternatives which is the most cost beneficial. Coming back to my favorite house example, having come up with a house plan and so on. Now we have a number of alternatives. Alternatives is, for instance, whether to use a mosaic floor or a granite floor, or whether to kind of put marble in the bathrooms. Okay. There are a number of alternatives. Different types of building materials become available. So you can look at two or three different designs in terms of materials. But if your architect is very cooperative, you can even look at 2 or 3 different looks for the house, and each of them look at the cost of them and the benefit by putting this new type of a material for flooring. It is going to be more expensive, but it is going to last longer. Is it worth it? Do I have the money to invest it at this time? Similarly, walls can be painted. There are so many types of paints available today. A cheapest paint or the most expensive paint. Now, what is the advantage of each? Even if I find the best paint has an advantage of 10 years, I don't have to do anything. I may not have the capital to invest it at that time. So the question arises that the best alternative may not necessarily be the one which is feasible because I don't have the money. Same way in a system. The system has to look at alternatives. The manager will look at the alternatives and say which alternative they look at. And in the case of computer based systems, what are the resources you have available? Human resources, time available, equipment, cost of each alternative, benefit, and find the best alternative. And then the feasibility analysis, you come up with the best alternative among the various things. Then you drop the final specification. So final specification is something which is signed by both by the customer who gives you the requirement. So first SRS, it's called SRS document, final SRS document, final system requirement design document. The specification will say what the system will achieve, what will be the after the implementation of what will be operations of your computer, which will of your organization will be improved, and what benefits will you get out of this. And you create a SRS document which more or less explains in great detail the system which will be implemented. And nowadays there is also a method called prototyping. What is prototyping is somewhat equivalent to the model which an architect makes. The cardboard model which the architect makes for you to look at is not the final house. It is only a prototype of what the house is going to look like. Similarly, nowadays what people do is, it is too late to kind of change things after you implement the system. So what you do is to try to come up with a model or a smaller version where there are so-called prototyping tools available on computers, where you try to kind of create the look and feel of what you will ultimately get in terms of graphical user interfaces, how the users are going to interact with the system, how will the data things flow, and so on. So this kind of a thing is called system prototyping, and prototyping is a very useful method nowadays which is available, and you show a prototype, and then once you show a prototype, that becomes a benchmark against which you will compare the final system. So there is something to compare against. Just like when an architect gives you a building cardboard model, that cardboard model is the one which is going to compare against the final house which you are going to get, and they should resemble one another. If they don't resemble, it means that something has gone wrong completely. Okay. So, effectively you are committing, both sides are committing to something. So, at this time users agreement on this SRS document is reached, saying that the user believes this is what he is going to get, I guarantee that this is what I am going to give. So, the SRS document is one of the most important documents which are signed by the contractor, in this case system provider, and the user or organization to whom it is given. So, the SRS document also gives the cost estimates and time estimates. How much time is going to take to build the system, how much will it cost, what are the benefits, and so there is a contract, and this contract is considered kind of a sacred contract, like a building contract. Okay, it's something which will even stand up in court, or normally it gets into arbitration. There is a disagreement after you deliver. There is a disagreement between you and the customer. Then you have to go to an umpire, for the umpire to decide whether who is not correct. So, if there is a good documentation, then the arbitration person also has something to look at, and if the prototypes are also there, there is something which as evidence which he can look at before deciding who made a mistake and whether there is a change to be made and so on. Of course, one hopes that one will never get into that stage, because that is a very uncomfortable stage for any company, both a company and organization to get into, and one would like to avoid it by normally trying to reach a consensus between the customer and the provider, and ultimately some negotiation takes place and they come up with the thing. See, otherwise you get into all kinds of problems. Now, of course, I talked about hardware study. What is the hardware and software required to execute the application? Are you going to make ready-made software? Are you going to build special software for this? What languages are you going to use? Are you going to use Java? Are you going to use C++? And these are questions which you have to decide. Response time versus volume of data processed, frequency of reports, all these things impinge on the type of hardware you require and the type of software you are going to use it. Is it going to be a web-based system? In this case, maybe Java type programming language would be more useful. So, there are a number of issues in terms of the method of the hardware and software is you need to do. And software system design, that is a step where you do a logical design of a system, and you write your what I would say is structured programming in English and stuff like that. So, program structure. So, you write a functional you write some kind of a pseudo English programs. You may use decision tables and so on at that stage. So, logically look at the programming aspect, and we are going to use object oriented programming, identify the objects which will go into the system, and database, look at the database design, what kind of design you will have. So, overview of these things, and program specification is drawn up so that you can have a set of programmers start programming it. You design have an implementation plan to implement the system. In other words, implementation plan again is some kind of a chart which will say how much time is assigned for each of these tasks. So you always work backwards. You contracted with the organization that you will finish the job in 8 months. So if you have to finish the job in 8 months, you work backwards with something called a PERT chart or a CPM chart, and you look at all the tasks starting from 0 to the end. You also find out what tasks can carry on parallel, what tasks will go on in series, and how much time will each task take, and how many people you have to put on each task. So all these things are part of the design. So implementation plan design. And who are the experts who know Java very well? If you decided on Java, you may have in the company a lot of Java experts. So you put those Java experts. And so in fact, the human resource department normally has a complete database of so-called skills inventory. And based on skills inventory, also decide they have some kind of a record on the availability of people. What projects are they working on currently? What projects they earlier worked on? So you try to see from this database who are the best people to work on this. Are they available? When will they become available? Because they may be on a different project, but they may become free after some time, at which time you can allocate to them here. So all these issues are part and parcel of the implementation design, implementation plan. And then you also have a test plan at that stage. So in other words, as I pointed out, when the system is delivered, that delivered system should work without any kind of a breakdown. If it breaks down at that time, it is extremely bad from the point of view of the organization as well as the provider. So you have to be fairly careful about deciding on what kind of a test plan I have to have, and this testing has got to be extensive, both system testing as well as program testing. And in fact, companies are there now which specialize in testing. In other words, they will give a third party test. You give a system to them and they will do a third party test. So you must have some plan for that test. Internal test what you will do, external test what you will do, and the test plan becomes an important part and parcel of your system design. So it's a system testing, program testing, testing with wrong data, and all that part, which is what's called extensive testing. And as I pointed out, it's now companies are there which will do it for you. And test plan, as I said, is even before the programs are written, because the test, even before you write the program, if you have a clear test plan, after the program is written, you know how to test it. And for all the test cases, the program has to work. So test cases are very useful for a programmer also, because person can program and go right through it, and at each stage test it, so that at the end of it, it doesn't get into a great problem. There is also a question of many methods of programming are there in terms of, when you write a program, you ask somebody else to look at your program, and team programming, extreme programming. There are hundreds of techniques people talk about making quality programs. And so I am not going to be talking about all these things, but there are many things. As a create database and document system. documentation of the implemented system is extremely important. The reason why documentation is important is because, as I said, no system is static. The system is going to become dynamic. The system becomes dynamic, that means it requires change. If you have to change the system, unless there is documentation of what the old system did, you cannot change it easily. And software organizations, it turns out that there is a lot of people leaving and coming, people coming, earlier people leaving. They call so-called turnover. 15 to 20% of the people leave any company every year. That means the human resource is not a stable human resource. So because of that also, a documentation is extremely important. And very often companies do not pay enough attention to documentation because it is considered as something which is to be done at the end. But a good practice would be to create documentation as you go along, so it does not become a last minute hurried job. It also is useful to think about methods whereby separate documentation is not required. Documentation becomes part and parcel of your programs. If this is the method which you use or design, when it becomes part and parcel of a program, then documentation does not become a chore at the end. So there are methods which one has to follow, or standards which companies have, so-called documentation standards or programs. While you write a program, you kind of give plenty of comments and how to write comments and stuff like that. And then of course system documentation. These are parts which are part of what you are going to learn as you go along, but documentation is very important. Then as part of implementation, you also have to train users. Ultimately, the people who are going to benefit from the system are the users. Like for instance, if you have planned a new computer-based system for a bank, then the person who is going to use it day in and day out, the terminal, is the clerk or the teller in the bank, and the teller has to know what are the graphical user interfaces, what buttons, what keys to press for what function keys are to be pressed for what purpose. So training is very important for that person, and the system should be designed in such a way that operational people like clerks and so on, who are not very computer literate, must find it very user friendly to be able to do it without much of a learning period, very quickly. There also the problem arises. People are on leave in any bank, so they have to kind of redeploy, take some other person and put it in a place where a person is working, and that person should very quickly be able to understand how to operate that computer there. So it should be more or less self-learning kind of a thing. In other words, it should be possible so that without reading any manual, you should be able to start using it. Because you know, people don't read manuals. They try to attempt things and then they learn. So when you attempt things, if something goes wrong, system should not get into a hang state or loop and stuff like that. It should be able to gracefully recover and not do something very damaging. So these are issues which are very important. That is, you have to train users. And while you train users, you understand the users' problems, so that you will modify the system to cater to the users. You might say weaknesses or knowledge or lack of knowledge or whatever. Okay. So, you have to very clearly understand that today computers are used so universally by all types of people that whatever you design must be absolutely foolproof. So, any person with a reasonable amount of common sense should be able to use the system without much of a difficulty. So, you also do a trial run. What is meant by trial run is there are two types of situations which may arise. One situation is ab initio you are doing it. What is meant by ab initio is that previously there is no computer based system was there, only manual system was there, and you now put a computer based system. You run both the computer based system and the manual system concurrently or parallelly for some time. Like in the chemist shop, he has bought a laptop, you put all the programs, everything in it. Before he becomes comfortable, he will continue to use his old system, and he will also try to use the new system. And if he finds after say some days that the new system he can rely on and his algos the old system are better, then he will go to a new system. This is called parallel run. But if suppose while using the new system he finds some problems with it, then at least he can fall back on the old system. The whole place does not come to a standing halt or grinding halt. Same way, organizations which are new and implementing new things, they try to kind of have a parallel run. The other situation is you already have a computer based system which is running, and you are now replacing it with a better system. Again, they will run both the systems and match the results and see whether the new system at least gives you what all the old system was giving and more, what is promised. And is it doing much faster? Is the response time better? Is it giving me better thing? At least is it giving me old things without any change? So, that conviction has to come. If that conviction comes, then of course you have a tendency to accept. Then you have the testing. We test and accept. Test the system, because this trial run already will be a test situation, and you get an idea of that. And evaluation. Find out from the user system meets the specified requirements. As I said again, after running it for some time, list areas of dissatisfaction and find the reasons why they are dissatisfied. Suggest if there are any improvements which can be possible, which can come from the user also, because he used it some time. Going back to my house example, only after you start living in a house for 6 to 8 months, you know what's all wrong with that house. And you can tell your friend how not to build a house. This house they built, I am not satisfied because of the following reasons. So, when you build a house, don't do this. Of course, in the case of a house, he has to grin and bear it. I mean, there is nothing he can do about it, because other than just breaking it down, which is impossible. Whereas in the computer, it is a soft system, and they can change it. So, you will know what all is wrong with the system, and will kind of change system and suggest there any improvements which can be made, which you can implement. finally you modify, fix errors, add, delete new features, tune the system, and continuously monitor and assess performance. Okay. And that is, after evaluation you modify, and this of course after a period, and then this is always continuous in the sense that it is not something which is one time. It is a continuous thing which you do. There is every 6 months you may have a review and have a system modification plan and modify the system, because every 6 months, as I said, human system may change, your requirements may change a little bit. So to what extent do you want to modify only what is running, or do I have to go back and redo everything, and so on. These things are taken at this stage. Normally people do not modify every 6 months. They let it run for a few years, 3-4 years, and then maybe change it. Okay, because human systems have a much longer time constants than computers. So we really are satisfied. We kind of put up with it, and later on we slowly improve it and continuously improve it and optimize it. So that kind of concludes an overview of the steps in systems analysis and design.